Hello, this video's topic is multiplying matrices. While adding and subtracting matrices is really easy, multiplying matrices is a little bit tricky. But once we see how to do it, then it's not going to be a big deal. When we first look at it, it's going to seem really weird. But once we do some examples and think about what's going on, you'll see that it makes a lot of sense. So before we do multiplication, we have to check dimensions. So when we add and subtract, they have to have exactly the same dimensions. But in multiplication, it's not the case. In multiplication, the number of columns of the first matrix must be the same as number of rows of the second matrix in order for two matrices to be compatible. So for these two matrices to be compatible, I have to have the same numbers of columns in the first matrix as I have rows in the second matrix. As in this example, I have 2 by 3 matrix for A, 3 by 4 for B, so inner dimensions are same. By inner dimensions, I mean number of columns of the first and number of rows of the second. Once they are same, then we can say that these two matrices are compatible for multiplication. We can do this multiplication. So what kind of matrix we get when we do this multiplication? When we multiply A and B, the new dimensions become 2 by 4. The outer dimensions will give us dimensions of the new product matrix. So inner dimensions will determine whether we can multiply two matrices. If we can, outer dimensions will give us the dimensions of the new matrix. So when you look at matrix A and B here, you see 1, 2, 3 rows in A, 3 columns in A, and in B, 1, 2, 3 rows. So 3 columns, 3 rows. Or you can say from left to right in the first matrix, you cover 3 numbers, you are going through 3 numbers. In B, from up to down, you are going along 3 numbers. 3, 3. The numbers are matching. Then we can do this multiplication. When we do, we get a matrix whose dimensions are 2 by 4. Let's take a look at C and D. In C, we have 2 columns, and in D, 3 rows. In other words, from left to right, for the first matrix, we are going along 2 numbers in C. In D, from up to down, we are going along 3 numbers. Numbers are not matching, 2 and 3. 2 and 3, they are supposed to be same, to be compatible, they are not, so we cannot do this multiplication. We say C multiplied by D is not defined. Let's take a look at some examples. Tell whether each product is defined. If so, give its dimensions. So P multiplied by Q for the first question. P multiplied by Q. Dimensions of P 2 by 5. Dimensions of Q is 5 by 3. All you have to do is check the inner dimensions. Your inner dimensions 5 and 5. 5 is equal to 5, right? So number of columns of the first is same as number of rows in the second. They are equal to each other. Then we can say they are compatible. We can do this multiplication. So it is defined. It is defined. What about product dimensions of the product matrix PQ? The outer dimensions will give us the dimensions of the new matrix. So it's 2 by 3. What about B? RS. R here, S here. Check inner dimensions. 3 and 4. Number of columns of the first is not same as number of rows in the second. So those two matrices are not defined. Are not defined. Instead, let me say RS is not defined. So we can't do this multiplication. It is pretty simple once you get the hang of it. And what about doing multiplication? So now we did the first part. We determine whether we do this multiplication or not. Once we know that we can do the multiplication, how do we do the multiplication? So in these examples, we haven't talked about how to do the multiplication. We just see which matrices can be put together and which products can be found. What about multiplying them? Let's see how to do that. So let's take a look at an example and how we see how we multiply matrices when we're allowed to do it. First example, we have two matrices. 1, 2, 3, 4 is the first matrix, 5, 6, 7, 8 the second matrix. So first we have to make sure that we are allowed to do this multiplication. Are we allowed to do the multiplication? Look at the dimensions. We have two numbers here from left to right, two numbers up to down for the second matrix. Two numbers are matching, so we can do this multiplication. 2 by 2 matrix here, 2 by 2 matrix here, their inner dimensions are same, so we can do the multiplication. There are a lot of ways of checking whether we can multiply the matrices or not. So you either look at visually or write the dimensions down and check whether number of the columns of the first is same as number of rows in the second. So let me explain how to do the multiplication. First, we always have to multiply, use the rows of the first and columns of the second when we do the multiplication. We are multiplying rows of the first matrix by columns of the second matrix in order. So what is the order? So first, we take the first row of the first matrix and first column of the second matrix. First row of the first matrix, second column of the first column of the second matrix, and we multiply them in order. We are going to multiply first number by the first number, second number by the second number. We do this multiplication and add them up, like 1 times 5 plus 2 times 7. 1 times 5 plus 2 times 7. So this is how we get the first entry. What is the address of the first entry? The address of the first entry is P sub 1, 1, right? So 1 represents the first row, the other one represents the first column. So to find the entry in P sub 1, 1, we have to use first row of the first matrix by first column of the second matrix. This is how we multiply two matrices. So we got the first entry. What about the second entry? Let's continue with the second entry. So this time we multiply the first row of the first matrix by second column of the second matrix, because the address here for the second entry is P sub 1, 2, right? That one represents we have to multiply first row of the first matrix by second column of the second matrix. So 1 by 1, 1 by 6, 2 by 8. Multiply them in order and add them up. So 1 by 6 plus 2 by 8. So this is the second entry, and we are done with the row, first row. Let's do the same for the second row. For the second row, what is the address here? The third entry, the address is P sub 2, 1, right? Second row, first column. That means we have to multiply the second row of the first matrix by first column of the second matrix. So second row of the first matrix by first column of the second matrix, 1 by 1. So 3 by 5, 4 by 7. 3 multiplied by 5 plus 4 multiplied by 7. And we are done here. For the last one, the address is P sub 2, 2, meaning you multiply the second row of the first matrix by second column of the second matrix. First second row of the first by second column of the second. In order 3 by 5, 4 by 8, 1 by 1, and add them up. 3 by 6 plus 4 by 8. And we add them up. 1 by 5, 5, 2 by 4, 7 by 2, 14, 14, 5, 19. Here 1, 6, 6, 2, 8, 16, 16, 6, 22, 3, 5, 15, 4, 7, 28, 28, 15, 43, and 3, 6, 18, 4 times 3, 4 times 8, 32, 32, 18, 50. So this is your product matrix. Let's do one more example. Okay, multiply matrix W by matrix X. Okay, first we are going to multiply the rows of the first by columns of the second. So for the first entry, we are going to multiply the first row of the first matrix by first column of the second matrix. So 3 by 4, negative 2 by 5, and add them up, we get 2. Similarly, for the second entry, first row of the first matrix by second column of the second matrix, because the address here is 1, 2 spots. So 3 by 7, negative 2 by 1. Add them up, you get 19. Now we are in the third. For the third, we are going to use the third column. We are still in the first row, so we still use the first row of the first matrix, but we are in the third column. Multiply it by the third column. 3 by negative 2, negative 2 by negative 1 gives you negative 4. We are done with the first row. Let's do the same for the second row. So this time you continue with the second row for the first matrix. And for the first entry in the second row, we have to have the first column of the second. So 1 by 4, 0 by 5 gives you 4. And for this entry, we are still in the second row. Second row of the first by second column of the second. 1 by 7, 0 by 1 gives you 7. For the last column, for the last entry in the second row, we have to use the last column. So second row of the first by third column of the second. 1 by negative 2, 0 by negative 1 gives you negative 2. We finished second row too. Now we will do the same for the third row. So let's do first third row of the first by first column of the second. 2 by 4, negative 1 by 5 gives you 3. Continue with the other column. 2 by 7, negative 1 by 1 gives you 13. And finally, the last column of the second, last row of the first, last column of the second. 2 by negative 2, negative 1 by negative 1 gives you negative 3. So when you do some practice, some exercises, then it will make a lot of sense.